Welcome. Let's talk about some physics. Now, if you remember when we were doing derivatives, we talked about the derivative of position is velocity, and the derivative of velocity is acceleration. So acceleration is the second derivative of position. Well, if we're doing anti-differentiation or antiderivatives or integrals, we're going to go opposite. So if I'm given acceleration, I can go backwards or integrate to get velocity, and then I can go backwards or integrate again to get position. So let's talk about this. Here we have an acceleration equation. Also note, I have initial conditions. So that means this is going to be a two-step problem like we talked about in the last video. So our first step is going to be to integrate my acceleration equation to come up with my velocity equation plus c. And then step 2 will be to plug in my initial conditions to solve for what c should be. So I want you to pause the video, try and do both of those steps on your own, and then come back and see how you did. Welcome back. Let's see how you did. Okay, first I took the integral of this equation, and this is what I came up with, 2t squared minus 3t plus c. Then I plugged in my initial condition, so 1 for x and it equals 6. To solve for c, that I got c equals 7. So here's my final equation where I replace c for 7. And there we go. Now let's work backwards again to find the position equation. And this is going to be the two steps again where we're going to integrate the velocity. And it's going to give us an equation plus c. And then we're going to use our initial condition of s of 2 equals 5 to find what what c would be and put the whole equation together. So once again, I want you to pause the video, try these two steps out on your own, and then come back and see how you did. Okay, check what you got with what I got. Here's the equation that I got when I integrated. And then I plugged in my initial condition and got some fractions, so it got a little gross in the middle, but I got c equals negative 25/3, which I then plugged in to get my final equation. And there we go. Okay, let's try our last example. This example is a physics problem that is only using the acceleration of gravity. So kind of, you can think of it like an object in free fall. So if I have an object in free fall, it's falling at negative 32 feet per second squared. That's the acceleration equation due to gravity. Now I want to use that particular acceleration equation due to gravity to find velocity and position, just like we did in the last problem. And we even have an initial condition. So our first step is going to be integrating acceleration to get velocity. And our second step will be plugging in the initial condition. Now, notice instead of a number, we're using a letter, but this V0 might as well be like 10 miles per hour. Or since we're in feet per second, like 32 feet per second, or like 98 feet per second. So whatever that velocity, that initial velocity is, this is just a number. It's just a constant. So I want you to try these two steps on your own. Find the integral equation plus c, and then plug in your initial condition, and then come back and see how you did. Okay, here's the equation I got, negative 32t plus c. And I plugged in my initial condition, plugged in 0, and it equals V0, which is just some number. So I got c equals V0. By the way, I'm saying V naught, N-O, kind of like N-O-T. That's what we say whenever it has that little 0 next to it. So this would be S naught. Anyway, let's do this a second time to find the position. So we're still going to do the same 2 steps. We're going to start by integrating my velocity and then plugging in my initial condition. And once again, S naught and V naught are just numbers, not letters. So treat them as if they were a number. So pause the video. Try this part out where you integrate and then solve for C to put it all together. Come back and then see what you got. Welcome back. Let's check what you got with what I got. So when I integrated, this is the equation I got with my plus C. Then I plugged in my initial condition to find that C equals S naught. So I plugged that in to get this equation. Now, if you got it wrong, it probably happened right here at this step, because remember, V naught is a number. So this is our constant rule. So this is like the integral of 12 dt. It's just a number, so we treat it like a number by just adding a letter onto it. So that should be all for today's lesson. You can go ahead and get started on your assignment.